Today, we are named as the top 50 AI startups in the world. We are also named as the top 50 medtech startups in the world.
If you're a layman, can you explain how the brain works?
Each of them is like a layer of a Google map. Your water diffusion gives you your roads in the brain. Your oxygenation gives you your traffic in the brain.
You can implement it on neurosurgery, neurology, psychiatry. So medical devices have started utilizing our platform for doing validation for their own devices.
So 12 o'clock at night, this patient's MRI data is coming. Our computational algorithm processes it, team checks it, and then it's sent back and it's on the surgery table at 7 a.m. in the morning.
How brain perceives perception, what is the consciousness, where it lies. So eventually, if we have significant amount of data, the world can explore beyond imagination.
You need a technology of ambition. In India, everybody needs to be equally ambitious about building a world-class company, which means that you need investors who are more long-term thinking. You need the government policies to be more long-term thinking. You need the founders to have worked with international startup founders.
What has been the emotional cost of building this organization? Hi, welcome to the We Women project. Today's guests are working on a problem that lies in the intersection of artificial intelligence, healthcare, neuroscience, and one of the most complicated problems that the world would seek to solve, the human brain. I have Laina, Emanuel, and Dr. Rimjhim Agarwal, who are the co-founders of Brainsight AI, which works on creating graphic tools, connectonomics, and other aspects that help clinicians, doctors, and neurosurgeons understand the brain better and help them in surgery. Am I right in saying that?
Indeed.
Great. Okay. So welcome to the project. And thank you so much for taking your time out and doing this for us.
Thank you so much for having us. Thank you.
So I think, how did you all meet? As co-founders, how did you all meet and what's the background?
So, we met in Entrepreneur First. It's like speed dating for entrepreneurs who want to build their own startup. They get 50% of the domain expert, technology experts, and 50% MBA business background experts. And that helps in the people who are from the deep tech background helps in creating
domain expertise.
Yes. And they work together, build an idea, and then build a startup, which they do a pre-seed funding kind of thing. So we met over there. So when we were working, Laina was like my third co-founder, and I was like fifth co-founder.
Both. Yeah, true.
Yeah, so many experimentations we did with other people, and finally, when we started working together, it clicked. We both wanted to do something in impact and healthcare. So yes, that was.
So you can do a co-founder speed dating.
Indeed, and it's so. I think I had just before meeting her, I'd gone to this MIT boot camp in Brazil, and it's like this very disciplined way of how do you go about entrepreneurship. And their step 0 was find a co-founder, and I'm like, okay, how do you find a co-founder? Because most women and most people would only hang out with people of their own genre, right? Like if you're from a B school, you'll hang out with somebody from a B school. Journalism, you'll hang out with somebody with journalism. And the key to a good startup, according to research at least, is having people with complementary skill sets. And that's very hard to find. And I think this program was really good at putting together people with complementary skill sets and then just allowing them to speed date and figure out if they want to work together.
Lovely. Really wonderful. So what were you passionate about and why the startup thought process in the mind? What were you working on and what did you want to do?
Right. I had a very varied career. I started with like coding operating systems at NetApp and before that at Infosys. Then I wanted to do something more impactful, went into public health. So I was working on a number of different public health as well as more international development issues. So looking at things like your vaccine delivery. I worked with the government of Madhya Pradesh on maternal mortality. And so a number of those kind of things. And I really enjoyed that. I mean, I think I love the impact side of things, but I also missed the speed of my earlier work. Software has a speed which I don't think international development has, and so I had sat down and I'm like, okay, now I need to kind of build my career further. How do you kind of bring the two together? And the only thing that could at that stage, right, like it's very hard to follow a proper corporate path. Even if I wanted to follow, I don't think others would have wanted me to follow it, because you don't climb a corporate ladder by jumping across different things, right? And so then the best way to kind of fulfill my ambitions was to start off something. So that's how I came to this program, basically. Yeah.
So I was doing my PhD in NIMHANS, but actually I started doing my PhD in this field itself because I had interest in neuroscience. I had interest in actually two things when I was doing masters. I got interested in cancer and I got interested in brain. So some of the projects I've done is in cancer as well, like Comet essay and understanding DNA involvement in cancer, etc. Actually, I've done my BTech in bioinformatics and MTech in biotechnology. But when I was doing biotechnology, I realized that translation in biotechnology is much longer and results are much slower. And looking into the biology domain from the technology domain, from the coding domain, would be much faster in terms of getting the results out, and also exploration could be much, much wider. And that's how I thought about getting into more bioinformatics-led domains. And I did my internship in NIMHANS Bangalore, after which I stayed in NIMHANS Bangalore and did my PhD from there as well. I finally got admission in PhD in 2015 and got it done by 2019. That's when we started. I was just finishing my PhD when I got call from Entrepreneur First. I then filled the application and got into this program. So that was that. However, psychiatry always excited me because it is very complex, unknown. A lot of it is unknown. So that's why PhD in machine learning in psychiatry specifically.
Even the skill sets you have bring in, no, it's almost like a match made in heaven, right? At least from a brain
True. From
perspective.
From the complementarity perspective, I think we really kind of fit well together. And I think it would have been very hard to find this if we had searched individually in our own set of people we know. So yeah.
It's lovely. So, when did you think AI, like you've been using technology, you've also mentioned technology, but when did you think AI was the answer, or AI was what you would want to work on?
I don't think we ever thought of that as this thing, but yeah, I would love to know.
Early seeds of problem solving. What is the problem that you wanted to solve?
So in the psychiatry, in neuroscience, the dimensionality is very huge. It cannot be interpreted by humans just like that. Like there were evolution, computational psychiatry, computational neuroscience, translational psychiatry, translational neuroscience. These are some of the evolutionary pathway of what has happened, and it led to machine learning because the dimension of the data set that we are handling in this domain is quite huge, and it can only make sense with something more advanced. And that's where machine learning came into picture. So it's a necessity in this field because when you see we are dealing with 3D data set in which is a time series, which is like millions and millions of voxels and pixels that we are dealing with. It cannot be, humans cannot just look into it.
I was just for a layman. I'm a 10th pass science. Okay, for a layman, can you explain how the brain works?
Oh, brain working cannot be answered. Like brain works in a very complex way that we have as a human have not understood, even though it is on our head and everyone is roaming around with the brain. So it is very hard to explain how brain works. However, we are trying to make sense of some of the functionalities which could be useful for medical purposes. So for example, when I'm speaking, I'm looking at something, I'm coordinating, my body is coordinating, which is all done by the brain. So we are trying to define those, understand those functions, define some part of it and present it in front of the clinicians so that they can utilize it for particular treatment. So we are just exploring some part of what the overall functionality of the brain is. And that's what we call as network maps and functional maps of the brain that we provide to the doctors. for navigating for surgeries and performing surgeries without functional losses.
I'm going to try attempting, reframing this question a bit again. So, there's, at least for a layman, it's the left side of the brain, the right side of the brain,
okay.
or the lobes,
Got it.
or the heaviness. What
Got
is
it.
it that
So
gives insights?
Okay, so I think so. What you're saying is a very natural evolution. So earlier, like I think even from the 1600s onwards, the brain's being studied, right? And in fact, even earlier. So I don't know much about that, but you'll see that the earlier way of looking at the brain is a very locationist way. Like you kind of try and say that this function is associated with this part of the brain. There were lesion studies which were done to kind of look at um, how patients with a certain part which is not working, what is the impact on the patient, right? Like I think there were all of those. Now as maths has evolved, right, there are newer ways to kind of look at the brain. Like there's network analysis, there's topographical analysis. There are also very many new methods of analyzing the same data as you go forward. So I think what has changed is from a locationist perspective, we've moved to a more network perspective of looking at the brain. How do different parts get interconnected and hence lead for a human to be able to do the functions that they're doing? And I think that's what has changed. And that's the perspective that you're able to bring with the kind of data that we are able to give to doctors.
So the transmitted messages from the neurons, is that what?
Yeah, so
it is?
in the brain there are like billions of neurons and they are shooting at each other. There are two ways in which they communicate. One is the chemical way and another one is the electrical signal. There is mild potential which is generated within the cell. And one part of the brain is communicating to another all the time. There are so many functions which are happening at all the points of time and they are coordinating. There is no particular way. So people, like you were saying, left brain versus right brain, it's usually not the case. There are some functionalities which are more left driven and some are right driven. Very rare cases, however, both the hemispheres are equally involved in various functions of the brain. So like even when the language is one of the functions which are lateralized, which is that some people utilize more of the left brain as compared to the right brain, and that is very useful in the surgeries as well. So if the surgery is in the right hemisphere, then they are little more relaxed to take out the complete tumor or as much as extent of tumor as compared to the left hemispheric brain, because the language region, if it is impacted, it will impact more of the language. But it is not specifically that logic is in the left and art is in the right. That's not at all. It's a myth. It's a myth.
Yeah.
Yes. And there are various parts of the brain like frontal cortex, which is developing more. And we say that as human, the frontal cortex has become more bigger because we do more cognitive functions. A lot of cognitive functions are concentrated, but doesn't mean that other parts of the brain is not involved in the cognition. These are some myths which are out there, but yes, there are some, we can say yes, these are performing, maybe these are the hubs of doing those connections, but not particularly only reason for those functions.
7 years since Brainsight has been in existence. So, how has the journey been? What is it that, where did you start and where are you today, if you can kind of please?
I mean, it's been a learning journey, if I could say. I mean, I think more than anything else. I think from the two of us coming in, so neither of us have medical device background, right? And I think being able to kind of make our way into selling medical devices is a whole different ball game altogether. And so when we came together, we just had this idea that, hey, we'll work in psychiatry because it's phenomenal to be able to work. But then I think once you start sussing out the market and asking them, what is it that they will buy today? We evolved. We realized that psychiatry is probably 5 years later for us. And we need to actually really focus on something that will make us money. I think the pressures of a startup are very different than the pressures of translating research. And so how do you kind of take your shareholders' interest, and how do you make sure that you're going on a path which will make revenue? And in a deep tech, you don't get the sense of revenue immediately, right? Like you get it 5 years. So you have to make a lot of hunches about what might work, and you need to be broadly right than broadly wrong. And so that broadly, how do you hone your own intuition to be broadly right most of the time about a space that you don't know about a space that the world doesn't know about, because there was only one another company at that point of time who was doing this medical connectomics. So how do you kind of, as a team, take the collective intelligence and try and build your intuition about what might work 3 years down the line? That was quite a journey for us, actually. Yeah.
Wow. So how did you break it down? Like, what did the first 6 months look like? What did the
Oh my God, first 6 months.
I do.
It was quite exhilarating because, like, entrepreneur first, they ask you to build a company within 3 months, and then they decide at the end of the 3 months whether they are investing in you or not. So therefore, it is quite intense and urgent program, where initially within 1 month you have to find out a co-founder in the cohort and start working with them, find out that you have an idea together to build something where your skill set is utilized, both the co-founder's skill set is utilized in 100% capacity or maybe 500% capacity. Because on daily basis, when I used to go back home, even in my sleep, I was like getting ideas and like, oh, this will work, this will not work. That
True.
was the case for first 3 months. And then within when we started working together, within 15 days we started talking to so many doctors. Laina had some good connections with some of the psychiatrists in US also, and in UK we spoke to internationally 27 psychiatrists to understand whether what we are planning to do will work out or not, and all were saying the same story. Then we thought that probably psychiatry will not work out, let's move to dementia. That is when we started working. It's in Max Saket, the hospital, and we got our first letter of intent from there. And from there it's like different sets of challenges every month. We got our pre-seed funding, then we went to Singapore, we pitched in front of around 300 investors, came back, realized we are too early, pitched in India to so many investors on, and she can tell about the investor story much more in details, how many rejections we have got from the investors, because it was deep tech, nobody else was doing. Even our competitors did not get anything by then. They were also very early, like 2.5 years, and we just got to know about them. We were the only two company in the world doing something like this. And eventually we started getting some interest, and then COVID also happened in between. So
19.
yes. So we got an office space
We
here
got
in
an office
Cold.
space in October, and I think
January and
January.
March. this thing
January
happened.
and March was when we decided we had to give it up and we had
Yeah.
to negotiate to get back rent and stuff like that. But yeah, March was when we took the decision that we need to go
Yeah.
back.
slowed you down a bit?
No, like,
I think in some ways, and in some ways, it probably helped us do a lot of things, because suddenly doctors were much more amenable to working online. So doctors they have such a busy schedule, and so often they don't like to do anything online, and they're not used to it. But I think during COVID, two things happened. I think doctors were forced to go online, and two is at least the neurosurgeons and neurologists who of course they were all diverted towards COVID, but but I had a little bit more bandwidth, and because they were also doing COVID work, they also wanted to get back to what they were doing, right? And so the fact that we were talking to them online about some of the most cutting edge research in this space was something they entertained, and it worked to our favor in some ways as well. Yeah.
the other side of it was that MRI was not done. We were majorly MRI based technology, and MRI stopped having. We stopped having MRI, specifically research led MRI was not done, and only essentially who would want to go for MRI for surgery, etc. Those were done. But back then we were not getting the surgery data. We were getting mostly for dementia and such kind of data sets on which we had to build the technology. So we stopped getting those, and therefore we needed to move to exploring more of the mobile based application. So almost for 1 year we worked on mobile based application to build for caregiving and other things. So that in kind of derailed our focus for a bit, but then as soon as this came back, we started working back in the MRI domain.
So I think on an immediate sense, what we're solving for neurosurgeons is when they're conducting a surgery, they conduct it from their intuition and their years of training, right? However, there's a lot in research about new things that we've learned about the brain and about how to understand functions. How do you translate that knowledge to their surgery table so that when they are conducting a surgery, they're able to see that information in front of them? So that's the immediate problem that we are solving. But I think our larger vision is to look at the brain. So we believe that the brain is a significant part of any disorder, right? Like, and specifically your brain disorders, psychiatric disorders, there's this dichotomy that psychiatric disorders are very different than brain disorders, and which has implications, right? Psychiatric disorders are usually considered as disorders of character more than they're considered as disorders of that something's wrong with the brain, right? Yeah. So how do you kind of create? And similarly, on the other side, when you have brain tumor and Parkinson's patients, they undergo depression. They have differences in their brain which lead to psychiatric implications. So there are all of these. You need it as a continuum of care, and that's not just for brain disorders. You look at maybe gastrointestinal disorders. There's a way that you can include the brain in it to lead to faster recovery. And what we believe is that the brain should be a big part of brain, and social determinants should be a big part of how you look at healthcare. And so for any kind of disorder. And how do we get there? I think neurosurgery is the start. We're getting into neurology and psychiatry now, and we get there. And
so you will keep going back to your passion, which is psychiatry. That's the sense I get.
At least for me, yes.
Yes, psychiatry. So I see this as, if you know brain, you can implement it on various things. You can implement it on neurosurgery, neurology, psychiatry, neuroanatomy, functional part of it, medical devices. So medical devices have started utilizing our platform for doing validation for their own devices, understanding how their devices are impacting brain. So if we know brain, there is overall so much to unfold. Even in small bits and pieces of information, we can do a lot. And for me, it is much more like our brain cannot interpret dimension beyond something, because there is a perception which is coming into picture, how brain perceives perception, what is the consciousness, where it lies. So eventually, if we have significant amount of data, we would be probably everything about brain. And people can explore and do research on top of it. It would be a layer on which the world can explore beyond imagination. And we are building that kind of data set, working with the hospitals, working with researchers, working with so many other domain experts. So that's the thought process for me. It's much bigger than what we can imagine.
So what is a data set? How do you build this data set? What constitutes?
Okay, the data set overall consists of macro level pictures that we are getting from the brain, which is MRI. Structural MRI is like 3D image of the brain, and functional MRI 3D time series, which shows of where the oxygen is getting consumed in the brain. If the oxygen is getting consumed in one part of the brain, which means it is working more actively as compared to the other, or if they are working simultaneously, that can also be looked into. So we are looking into the voxel, which is a unit of picture in 3D. Pixel is the unit of picture in 2D. Voxel is unit of picture in 3D.
Volume. It's a volume pixel. So voxel, basically. Yeah.
That's why it is a voxel. And that is what we analyze interaction. And it could be a box which you maybe 1 mm big, or you can do sub mm as well, like 0.1 mm. So you can define the size of the voxel and see how the intensities are changing. There will be billions of voxels working together, and that's where we see how simultaneously they are working. It's a time series analysis. However, we have not reached a time series analysis in company yet. We would do it in coming future. That's the evolution.
However, the smaller voxel it gets is more intense, goes deeper.
I mean,
is that how the mapping?
Not necessarily, but basically, I'll go back to your earlier question of what is the data. So, as she said, there's a structural MRI, there's a diffusion MRI, which looks at water diffusion in the brain. And then there is the functional MRI, which looks at oxidation in the brain. And the way I explain to people is each of them is like a layer of a Google map. So you have a structural map, gives you your buildings. your water diffusion gives you your roads in the brain, your oxygenation gives you your traffic in the brain, and each of them together give you a comprehensive view of a person's brain. Now, as she said, the voxel is the thing that we analyze so as to be able to build the traffic map. The water diffusion is the unit we analyze so as to be able to look at the water diffusion. So no matter what the size of the voxel is, it's the comprehensive picture that really matters.
Connectome is in a singular, is a unit of connection. So if my brain right now, multiple parts of the brain must be working. If I isolate one function and see how it is connected plus how they are performing simultaneously, one function, that is the one single unit called as connectome. And when we do connectomics, it's like multiple functions, multiple connections, and simultaneous working of it. We are analyzing together, and it is connectomics.
Thank you for being so patient with me.
No, I think this is a very new area. So I think a lot of it's new. I think we are on a daily basis. If you see the number of research papers our team is anyway reading and trying to keep up with the neuroscience research, we're learning new things every day. So I think, yeah, it is.
So, what is a good use case today? I mean, where you said you had to work for the investor or, for the unit economics to start working, right?
Correct.
So, what is a good use case that
surgery is the best use case today? I think today we have doctors in over like 65 hospitals where they're contracting and buying what we're doing. And then there are another 40, 50 hospitals where demos are ongoing and people are using and finding value in what we are doing. Because in surgery, often what used to happen was, so the doctor's intuition is there, right? Like as to, he opens the brain and he can also see the tracks. The tracks are very visible, right? Like, and so he can kind of figure out landmarks in the brain and then hone his intuition. But what would be helpful is to also get like an imaging proof of what he's thinking. And so the one function that could get mapped using clinical tools was your language function. So there's a thing called a task-based fMRI, where the patient goes into MRI machine and he speaks. And as he's speaking, those areas are getting activated, and that the doctor gets. That's the easier one. But to get a sense of all the other functions, they really did not have any tools. So a lot of the intuition was built around, so you have your language, which you're trying to preserve, and then you have for all the other functions, you're trying to use your intuition to be able to build. So we are now able to give those maps for the other functions as well, using a much more compactor MRI. So your TB fMRI is like a 40-minute thing. Your resting state functional MRI is a 7-minute thing. It's less inconvenient to the patient. He doesn't have to go in. And so think about this, like a patient, I think this was from AIIMS Jodhpur or something. So these task-based functional MRIs are very carefully calibrated by international companies. So there was this doctor who told us that, hey, the patient was in the MRI machine and we were showing him pictures and he was to identify. Now, one of them was a chaise lounge. And so the doctor's like, I don't understand what a chaise lounge is. Here's this guy who's come in like a second standard pass. What are you expecting him to identify these things, right? So your careful calibration is also very international specific. So your task-based functional MRI doesn't work a lot. It doesn't particularly work for paralyzed, comatose people, young, very old. So for a lot of reasons, this doesn't work. And hence your resting state functional MRI, when you're able to use that with a 7-minute, the patient just has to go and lie down in the MRI machine, not sleep. That's the only hard task, really. You don't have to sleep in the MRI. You can get to sleep quite because the sound is quite intense. But yeah, that's it. And then you get these maps. So
these models get built by real-time data that comes from this resting MRI?
Not real-time. It's
not real-time, but over a period of time, you would have collected the data points. I mean, real-time was a wrong usage, but data that comes from this resting MRI would have gone
correct.
Into the model.
So the patient comes in the night before and he goes through the MRI. So we often get data at 12 o'clock at night and all, and the surgery is 7 a.m. in the morning. So 12 o'clock at night, this patient's MRI data has come in. Our computational algorithms process it. Our team checks it, and then it's sent back, and it's on the surgery table at 7 a.m. in the morning. So,
and what is the accuracy that?
So in this one, I will just add to how it is not real time, but it means that we are giving specific network maps, like how usually the person will have activities in the brain. It's an average map that we give to individualized average map of the person to the doctors for doing a pre-surgical planning, and during the surgery it feeds into the neuro navigation system, which is very similar to how the mobile GPS Google Map navigation system works. They have a probe. When they move it up and down, the image also moves up and down. It doesn't need to be real time. We are looking into some real time use cases as well. We are exploring those, but it is slightly far for now.
My question also was that this model, this data goes and hits a model, right? So the model was built on this data set.
yes.
On the MRI, resting MRI data set over a period of time.
Resting state MRI and diffusion MRI both. So we have different models which work on these two. Yeah.
Okay. And what has been our accuracy?
Yes.
So accuracies are okay. So we, like I mentioned to you before, there are multiple layers to it. We are utilizing 3 sets of modalities. We do denoising for each of them. Each of these denoising step would be, for DMRI, we would have some 15 to 20 steps. For fMRI, we would have 26 steps. And then for structural MRI, we have 6 to 7 steps. And then extraction of the signals, classification of the signals, and then putting it all together in a coherent manner, which we call as information engineering, and providing it back to doctors in the parallel table. So each of these will have different sets of model, and accuracies are different. Now the clinical accuracies which doctors are reporting is a different set of things. Like what we do, we did our studies. We gave them to utilize it in 30 patients. We saw how much language, now the language accuracy, vision accuracy, motor accuracy, each of these are also going to be different. So the accuracy lies anywhere from 85% to 98% for different models on different layers. Some are very, very easy, and easy in the sense like repetitively we are getting the similar type of results, 95% plus. Some are much difficult for humans as well, for doctors as well. There we get lesser accuracy and things like that. So the expert feedback is something that we report in the FDA studies, CDSCO studies that we do with the hospitals.
This is a very, very poor comparison, but it's starting to sound like the CIBIL score to me, the bureau score that we pull out in financial functions. So it's the same score, but each person views it differently or evaluates it differently.
Love that. I'm going to probably use that to build my worldview over time. Yes, absolutely.
Have any of you taken a personalized map of the brain?
Not yet. I want to, but at some point in time, not yet.
I have it.
Is.
I had it in my PhD.
Is that a proposition?
No. It's never like that.
Scientific.
So it looks okay. So whenever somebody's brain will be analyzed, it's not going to be different. Like, okay, this person is crazy.
Does it say something about us?
No, the science is not so evolved that you. What it's just personalized to you.
Personalized to us, and maybe only a medical person can understand. That was just a curious question.
So I think the medical interpretation of the results. So the physical interpretation, as she said, is very hard for even doctors. But once they understand, the medical interpretation is what matters for that patient. So doing it, so it's a matter of 2 sets of interpretation before there is any kind of conclusion. So I think when people look at their own maps and they'll be like, oh, hyperactivity, hypoactivity, creativity, I'm very creative. It doesn't matter. It doesn't work like that. No.
It's not one of those psychological tests.
No, not at all. I get a lot of these people who are like, hey, are you building a business which can be used for guiding children on their career choices? And I'm like, no. It's certainly not the case. You can't do it right now. The science has not evolved so much.
I'd actually parked this for later. Sorry, Rambi.
I was just saying that maybe it won't. I mean, it's probably not a correct direction because every person's brain evolves. So maybe giving output for a kid saying that they will become astronaut, maybe they will become architect. Who knows?
Yeah, correct.
So in this entire journey, what has been the hardest technical roadblock? Technical roadblock and a generic roadblock.
Do you want to talk about technical roadblock first?
A lot, because so functional MRI, task-based functional MRI works at a higher frequency. You can pick up the signals at a higher frequency and then analyze it. Resting state functional MRI is like a person going into the MRI machine and lying for 7 minutes, and then we are extracting that data of oxygen signals, also the water molecules that we are looking in tractography. It is basically how the water molecules are traveling inside the tract, and diffusion is happening, and that's what we are trying to pick. So these are at molecular level interactions which are happening, but we are capturing it at a picture level. So that itself comes with a lot of noise. Since functional MRI, resting state functional MRI is a very low frequency bandwidth, processing and generalizing this data, making it replicable, is not easy. So I had worked on this for almost 5 years before we started this company, and a lot of work on top of this has gone, and we are dealing with really, really complex data. So a lot of technical difficulties on the processing of the data, making sense of it, and then accuracy. So we will do something, and then doctors will probably, with their experience, tell that this is not correct or this is correct. And maybe the scientific layer of it is suggesting something else, and the clinical layer of it is telling something else. Similarly, it goes for literality, which we spoke about. Literality is looked into from the perspective of task space. So higher frequency will capture a certain functions of the brain. However, the resting state captures both the hemisphere more bilaterally, because there are a lot of neurological functionings happening, and that is true positive, but in the clinical way it might not make sense to doctor. It should be more lateralized for them to take decisions. So decision making layer versus the clinical layer versus the neuroscience layer versus how actually the brain is performing are 4 different layers which should be coherent to reach a particular conclusion, which at times are not very coherent. And experimentation on this versus the timeline we have to give for making a product is very different. Like one experiment, a particular PhD student is probably looking into 1/4 of a solution and for 5 years, whereas we have to immediately look into it and solve for it, experiment for it, and give back the solution.
Brings me a question on the operations, but I'll finish the other
Yeah.
roadblock and then come to.
I think when we started out, I think at that time we were only looking at resting state functional MRI, and I think we had done a survey of the radiology centers here, etc., as to how many had they done, and I think we had surveyed 7 of them, and they had done 10 of them, and they had done one resting state functional MRI in the past 6-7 years. And so it was not a commercially viable thing that they were doing, and hence they didn't really know the science behind it. So we had to, over the next 3-4 years, really build their appetite. And while building their appetite, we realized that we also need to do diffusion MRI because that's in line with their anatomical intuition, right? Mm-hmm. And so we had to, as a team, build the expertise for diffusion MRI. Now we are excellent at it, but being able to build that intuition and then being able to capture the resting state function in line with the diffusion MRI was something, and then being able to explain to doctors as to why the data is saying what it is saying, and being able to kind of put all the layers that she's saying, right? Like the intelligence layer, the clinical decision-making layer, all of these. That took a significant amount of time. And once you go to different doctors, each of the doctors want to know it in terms of their patient, right? Like they're like, hey, so there were doctors who would be like, okay, for my Parkinson's patients, show me. There'll be like dementia patients, show me, brain tumor patients. And each of these is a different problem, really. And so we had to really kind of, and in the beginning, when you're searching for a winning use case, you need to be able to understand each of them. Over time, we honed in on brain tumor, but in the beginning, it took a lot of time to kind of look at all of this and navigate all of this. And then once we honed in on brain tumor, we were then able to kind of build in it and be able to explain in it. We are now moving beyond brain tumor into other disorders. So there's that space which has come back about here's what we need to do for epilepsy, here's what we need to do for Parkinson's, etc. So that space of divergence, which will then finally converge again. And you need to do this fast to create shareholder value, right? Like Absolutely. You need to be able to, for a shareholder to get value out of this, you need to be in as many disorders as possible, which means that you need to put in processes that each of these becomes super fast. The understanding, the convergence, divergence space, all of that has taken significant amount of time to kind of build the company into that. Yeah.
Who picks up the cost, Laina? Who picks up the cost for a diffusion MRI or resting MRI?
The patient. So right now, once we've got our license and it's a commercially viable product, it is it's basically a cost to the patient. And so the doctor explains to the patient that this is why we think it's a good idea for you to go through a connectomic profiling, and this is the cost, and hence paid. I think in the early stages, when it was not licensed, it was always a negotiation because of course, it's MRI time, and MRI is one of the highest utilized assets in a hospital. They don't want to give it for research, right? Like, so you have to kind of figure out how you provide value to them so that they're okay to give up a certain amount of their MRI time for building this. So there was all of that. You're right. That negotiation also took significant amount of time to get that done.
And from a validation of model, so before this data from real patients started coming, what was the data source for the validation of model?
Multiple layers. We started with open data source. We showed, we went to a doctor, showed that, these are the things possible. We were looking into the dementia space itself. However, we did sprint where we were looking into multiple types of doctors as well in hospitals. We went and talked to neurosurgeons, and one of the neurosurgeons was like, this functional MRI would be more helpful for us instead of neurology, because we are looking into utilizing it in surgery. We do task-based MRI. So that is where we picked up the idea, and then we started working more and more in details of networks, etc. So that is where...
People willing to share data with you?
No, so we started with the baseline open data source first, showed them what we can do. Then we did collaboration, got more data from one of the hospital, second hospital, third hospital. And then these were all like ethical clearance done, and then scientific committee clearance done. Once they give us the permission to utilize the data, optimize it for Indian data sets, and then utilized it. And then slowly, when we started doing more and more pilots, we started getting more and more data set on top of it.
My question in operations is, so when you say 1/4 of the brain took 5 years, so do you collaborate actively with PhD students, research papers? How is it that you broad-base your knowledge?
We need to do it. I mean, I think right now we're so exhausted with the amount of work that we have to do itself. But I think as the team is growing, we're now also starting work with, we have now a research vertical particularly, which is focused on being able to support people in their research. And so as a part of that, you get to work with PhD students, you get to work with master students working under clinicians. And so you're able to use those and you're able to help them. And so it's like a
quid pro quo.
It's a quid pro quo. Yeah.
Also now we have 6 PhDs within companies. And the first department that actually worked is R&D, because we started working in the experimentation and building the data set. So that was the foremost things that we started working. So it was a lot of neuroimaging, neuroscience focus. People, some of them were not exactly from the PhD backgrounds. However, these people were also exploring. So we had a person who was very much interested in machine learning in the neuroscience and neurotech domain. So
Very talent.
yes, we get varied talent, and the person who's leading the research department right now, she is PhD in biomedical engineering herself and looked into EEG in the brain space before, along with functional MRI data. Then another person who's PhD, she is looking into the functional neuroscience part of it. So we and a lot of people started working in our company have also gained a lot of knowledge. Like we have another research associate for she's working on neuroanatomy, clinical neuroscience for past 4 years, and she has substantial knowledge. Day in and day out, she is reading 10 to 15 papers and things like that. So
you build in that internal muscle and collaboration.
exactly.
Over a period
Yes.
of time.
We also have collaboration with IIT Mandi. We had a collaboration with IIT Mumbai for a bit of time, and we also get a lot of interns who are working in varied neuroscience domain, and they want to contribute, they want to learn how things work in the industry, and it's an exchange of knowledge that happens as well. So at any given point, we would have 10 to 12 interns working with the team, and we have a lot of people from multidisciplinary background, and now we have a designer who understands neuroscience and yes, neurotech. We have product head who is looking into neuroscience part of it for past 7 years. So it's amazing to see how the whole team has grown and such
How the
expertise.
brain
also.
functions, opens and
Exactly,
adapts to
exactly.
multidisciplinary.
Yeah, absolutely.
yeah. Dealing with a doctor who's very capable and very self-assured, and you have very high knowledge base within. So it's
It is
where
quite
does the buck stop? Who calls the shot saying this is it, this is what we build?
So right
Between
now,
the two
it
of
is
us, yeah.
between two of us. It is also that we have to generate revenue for sustaining anything like this, and also the people in the team are well aware that only neuroscience part of it may not bring the money to the company. We have to cater to the clinical part of it, and also the translation is so beautiful that when they are working on something which is neuroscience driven, the translation of it looks so amazing, and it is changing the life. It is so we started getting first few set of surgeries, and we got feedback from doctors saying that this person went back to work after surgery within 15 days because the functional loss was negligible. The person can comprehend everything, and that first case where this happened, where we got the feedback with all the words from the doctors and getting to know that okay, we have handled this case, it was amazing to know. That was one of the milestone cases, and then we got so many more, and on daily basis the people who are more customer facing get those details and bring it to the people, and it excites everyone in the team.
Life changing, literally.
Yeah, no, it's so you have to. I mean, I think there's also that whole they get like when you're in a neurosurgery room and when an operation is happening, right? It's intense, and I think the neurosurgeons calling the shots. Everybody and everybody around needs to be able to cater to that, right? Now, in between this, if there's something which they don't understand, either because the science of it is not something they understand, or because they don't know how the science translates into clinical, it's the frontline people who get screamed at, right? Like, and so there's a whole bunch of like training and making sure, and you're in a life and death situation there. So you need to be extremely on your toes always. And so there's surgery happening every 7 a.m. and our team needs to be there. They need to be answering questions. They need to be ensuring they know the science, but they also know how to talk clinical, but they also know how to ensure that the doctor is not getting angry and all of that stuff. So it's
Very
quite intense. It is
Very intense.
Yeah.
Intense. We have team from who are there deploying, who are setting up the MRI machine for neuroradiology technician, then neurosurgeon. They get screamed at by nurses, and then and then coming back and then giving the knowledge to the team to translate it, and then the whole team at the back end who are doing neuroscience, neuroimaging, product design. It's a very difficult product to design also. Like neurosurgeons are never going to, what we have realized, we initially made a very good dashboard where neurosurgeons will look at the images. They don't come to the dashboard at all. They just go into the surgery 8 a.m. in the morning and come back like 10 p.m. and they don't have time. So all the systems should be integrated with their workflows. Otherwise, it won't work. So integration is a bigger part of this. as well. And we are solving, these are the challenges we have realized over years. So first year was the science bit of it. Second year was the validation bit of it. Also parallelly looking into the fundraising part of it. Regulation is the biggest boat which we had to figure out, because none of us come from the regulatory background. We had to get that knowledge from outside, and we wanted to do it right. So we made sure that the whole team is thinking about risk when they are making a product from the very basics. And we had to build it in the team so that every person is talking, okay, this would be the risk. And we started doing meetings more often and making it sure that it is coming. Regulation started coming from 2.5 years. We started doing the documentation, like submitting the document, but actually the work started much before from that.
Yeah.
It took 4 years for the regulation.
Pretty much, yeah.
Five.
Yeah,
5 years.
So I think when I had worked with governments pretty much a lot. And so I knew the kind of documentation you need to keep to ensure that regulators are confident about what they're saying. Now, in the Indian context, regulators have not also seen these kind of products. Software as a medical device is an area that regulators, it's a CDSCO which does it. They've been very used to looking at drugs and looking at trials around drugs and to looking at that data. Medical device is a new area for them as well. Now, AI in medical device is a yet newer area. In fact, even the FDA is building their chops around it and being able to convince regulators about what you're doing when you're doing AI, when you're doing neuroscience, when you're doing clinical SaaS, was a whole different ballgame. You need to be able to predict where the regulatory view needs to be, will be in like another. I think it's very similar in banking, right? Like you need to be able to predict where the regulations are going to hit in like another 6 months, and then be able to proactively build towards it, or be at least proactively able to answer the regulator, right? So we had to kind of build those chops in the team as well. So yeah.
So from an FDA approval standpoint, once the approvals come, does it stop there, or you can continue to research and keep giving an addition, like,
of course
you can do that.
You can actually, a lot of medical device companies, that's what they do. They give the easiest version first, and when I say easiest regulatorily, because you have a precedent device which has done something similar. You make sure that the device that you first get regulatory approval for is something that has an insurance code associated with it in the US. But once you've done the first one, you kind of build on that to get the next set of regulatory approvals. And so that's a very done thing in medical devices.
You call it device.
Yeah.
Is it a device that goes into, or both?
It's a software as a medical device. So
it's a category. So when she was saying that these people, CDSCO people and other regulatory bodies, they have not seen device. They usually have seen the hardware device. It's about the software. They have seen yes. So what they did, hardware is something which is utilized more frequently. So they know about how hardware can be handled, and that's why it falls under the medical device. But then eventually softwares came, which was independent of hardware. So then they created a new category called software as a medical device. And on top of the software as a medical device, now AI is coming. And a lot of countries and regulatory bodies, they have not created a new set of rules for AI in the software as the medical device. So that is where we fall. We fall in the category of software.
So if you look at software as a medical device, right? The thing is, you can't go with the specific specifications, and you go and tell them that this is how this particular device will work. Now, even as a software, you have to show that this is how but in AI, what you're essentially doing, the specifications keep moving, right? With every new set of data sets that are coming, the accuracy changes, things change. So there are now, within the FDA, there are two pathways. One is the pathway which is about a specific specification. You lock it.
Yeah.
You've done it with 100 data sets, you lock the algorithm, and that algorithm doesn't improve till you come to the next version of the FDA that you put. Then there's a second one where you can say that this is going to be a device that actually improves with every data, but you then provide them a proof or a document which says that this is how we believe it will evolve. And if it doesn't evolve in this way, and you keep giving proofs to them that this evolves in this way, in the way that you imagined. So each of them is a different way of thinking and a different set of documentations that you need to keep as a team to ensure that they understand what you're saying. Yeah. So,
And this is for the intended use that we are writing. So we have to define this device will be used in so and so way by so and so people in such and such outcome and manners. But if you are building something new, either it will go as a new FDA application. So right now we are talking about tumor and our data being utilized by neuroradiologists and neurosurgeons. If we are doing something different, then it will go as a new. Yeah. So we starting with this, and that's why it is not just the first application. Any company in the medical device, and when they are launching the product, they will have multiple FDA application always going on. Yeah, parallelly.
Yeah.
And this will be patented, I would presume.
Yes.
Patented, of course.
Yes.
So explainability, we spoke about explainability, right? I'm just going to touch upon some AI, core AI sort of things. So how does explainability build in areas like this?
Initially, when we started, we took the data set to doctors. We started getting inputs from the doctors. Actually, the explainability needs to be in the language that they recognize the most, which is the clinical language. And we had to translate it in the form which can be understandable by them. So if we are presenting a number, it should be given in a certain manner, which is interpretable by the clinicians and experts. Okay. We had to translate into such manners. And it cannot be, so if a machine is saying that, let's say neural networks were known back 5 years, 7 years back, that those are black box and those are not going to give the explanation to doctors. If it is diagnosing, we are not in diagnosis, just FYI. So if it is, for example, diagnosing something and not giving the reasons, it is not palatable to doctors. They cannot accept that result. So we restricted keeping the AI ML, which is neural network based, into the layers where explainability is not required. So if we are doing just the signal processing, we can extract something or remove something. And also if it is visually possible. So for example, if we are removing, one example which I usually give is skull stripping. When we are processing the brain image, we remove the skull. If the skull is removed and we can see that image, it is correct, then we can utilize machine learning without explainability, because it is visually possible to do it. So for clinicians also, in the same way, either it should be clinically explainable or visually understandable. That is better when they can take it. And
initially we were the layer of explainability. So we would go with, like, for each patient, we had the data, we had the doctor has some clinical information which we don't have access to, right? So that clinical information, along with our information, along with us having read hundreds of papers in that space, to be able to explain to them that this is why this particular data might be saying this, right? And being able, so that was us doing it. And then over time, that guy gets coded into, as she said, the visual understanding. So earlier we used to give them graphs. And then one doctor told us, listen, I left maths in 10th standard. Please don't give me graphs. So then we were like, okay. So then we had to figure out how to do all of this onto an MRI, which they understand, right? So you take all of that AI things that you do and you bring it back into the MRI space so they understand. So that visual understanding is there. The clinical understanding develops between the two of us. And in fact, the product we are now developing is really a tool to aid in the clinical understanding. We don't have the full picture. They don't today have the neuroscience picture. How do we as a team help the patient best? That's what the product really needs to do.
We got a way to understand how we can utilize neural networks, and similarly now these new transformer models, etc. Right? And it would be eventually, it's about how you can explain well, how you can utilize well, and it is giving you the accuracies and serving the purpose what it is supposed to do. So it is going to evolve. Now we have also started using some of the transformer models. We know one of the competitors who is in this space, they are also using machine learning models. So yes, it is getting accepted in this space as well.
But I'll just add to it. So I'd gone to the American Society for Neuroradiology conference, and they had like this whole debate about the fact that does machine learning really help the doctors? Because they were all a bunch of doctors. And so they had this whole like debate, two very strong opponents debating it. And I think what they talked about when they talked about generative AI kind of models where they are used to build reports was that the doctor said that this is increasing my work rather than decreasing my work, because, hey, the junior doctor uses it, builds a report, and then the senior doctor has to spend additional time actually rebuilding the report before they give it. So the point being that if you have guardrails which ensure that the report, that you are only plugging into things that the doctor wants, that's when it becomes useful, rather than when you build entire reports or you do entire things with AI or with generative AI models. Doesn't work. It won't get clinical acceptance.
Okay. So everything using, keeping the customer in the mind,
Correct.
keeping the human in the loop in mind, and designing whatever you do.
Yeah. Very important in the medical space, for sure. And I think in the medical space particularly, because I think at the end of the day, the doctor is liable for the operation, right? Like, and I think for the outcomes for the patient, and it's life and death. So anything you do needs to have a direct impact on the doctor's way of working, to make sure that it is not complicating his life, or to ensure that he's not getting, he doesn't feel more confused by the data that you're giving.
Absolutely. But I like this one thing, that explainability was both of you in the beginning. So where it is greenfield, there is scope to just pick up pieces of information and start putting it together, explaining it to authorities and building from
Absolutely. You're right.
Founders should hear this then maybe.
Absolutely.
So, what is the scope of, not even scope, how do we avoid hallucination? How do you avoid errors in a field as critical as healthcare and brain surgery?
Yeah.
Some of the inputs, like right now, we look into each and every image because it is possible. We have that many volume, and we are looking into each and every outcome. And we have a layer of neuroradiology to make sure that clinically something markedly wrong is not going to doctors in the hospitals to take it up and utilize it. We need to make sure technically and at a level of clinical details we do that. However, when at the level of AI and machine learning, we also use a lot of basic neuroscience principles, which helps us to make sure that the difference can be picked up by neuroscience principles, or knowing the details of the machine learning itself helps. So for example, if I'll give you one example, if there is a track which is supposed to be in one place and it is not there, then we know that it is wrong. We know that a particular white matter region should be picked up. White matter, gray matter, these are some of the neuroscience details, anatomical details that we pick up and then correct it and look into the models as well. And then models confusion metrics are also considered, like accuracy, sensitivity. In our case, we need to be more sensitive as compared to specific. In certain use cases, we need to be more specific as compared to be sensitive. So all those are optimized further. And then the final layer of QA, QC happens with the clinician in the team and the technologists in the team. So they also do those checks. And then we also pull in all these data set and see out of 100 how many mistakes we have made, go back and improve the models. Now there is this process which is happening on regular basis, which helps us in making sure that the errors are minimal. We have corrected a lot of such errors. Like every cycle, every month, we will know about something new and then we will correct it further and the models will evolve. So that has happened eventually.
Did you think when you started off that, you would reach this point of creating something like this? And two, what is it that you've created that cannot be replicated by anyone in the market?
I would say our team. Our team is I think being able to build this team and to be able to create a team which, surpassing this interdisciplinary, differences, is able to talk, requires a lot of emotional quotient as a team. And I think, and it requires very specific processes that we have in the team, like we have things like governance meetings, stuff like that, be able to kind of create the space for talking. I think being able to create that emotional quotient, a high emotion quotient team,
High EQ, high IQ.
high EQ, high IQ, and
That's
high
a-
curiosity
high curiosity.
quotient. It has to have these three things, and to create that within the team and allow people to be curious while also delivering is a very hard thing to do. And I think we've got that right. So I think that's probably my thing. Yeah.
How does this scale? I mean, the opportunity is for me to see, and I think for everybody to see. So how does it scale? Because there are so many elements: the training, the research, So what are some of your thoughts as co-founders?
So I think brain surgery was always for us the smallest part of it. Was important. It was an important step because brain surgeons actually look and are able to validate what we do, right? And which is very different than neurology and psychiatry. They're not opening the brain, right? Now that they know that and they are able to talk about us. In fact, if you go to across the country today, neurosurgeons know about us. They vouch for our work. They talk about our work. And now that they have done, we are now moving into neurology and psychiatry. We also have a separate division which is focusing more on being able to provide results to researchers who, as she said, right, like much more fine-grained details that they need than clinicians. So those are two areas that
Maybe depth and then breadth.
I guess. I think till now we've been early years we were focusing on breadth, then we converged and focused on depth. This time is again a little bit of breadth, and then we kind of build into neurology and psychiatry, almost T-shaped, right? Like you go a little and then you go deep into one, and then you kind of go. While the research piece is a lot of the things that you're doing here, but you give in fine-grained manner to the researchers. So this is kind of parallel to each other, though there are a lot of additional things that need to be done. That's how I think we will keep building as a team.
Actually, what are your, medium-term goals, long-term goals? Apart from I understand the TE and the depth and all that, but more from a commercial sense.
I think so. Now we are in, as I said, 65 approximately hospitals which are commercially working with us. We need to get to a larger number of hospitals in India. Within this thing, I think we need to get, when you work in a hospital, once you get the first 4-5 cases right, you need to build it into a habit, right? Like today, it's not a habit because we have to remind them that, doctor, if you do this, hey, it will be really useful for your patient. So being able to kind of create that top of the mind recall in the surgeon's mind is a challenge that we have to solve this year. Then in addition, we are also internationalizing. As she said, we are doing our FDA process this year. So we are hoping to be in international markets by end of next year, at least by the minimum. So there's going to be a whole new set of learnings for the team as we go from like working with only Indian doctors to working with international doctors. Then also building our research vertical. So that has been one of our revenue generation in the beginning. And so being able to build on that as a team, that's another piece that we'll have to do. So these are three major, very big goals that we have to kind of address this year.
Both of you, as co-founders in a very greenfield area, you contribute to policy making in the country. Both of you, or I've seen you represent in the AI summit with the Prime Minister, etc.
Yes.
So what is India thinking? How are you contributing to the policy making?
I think in terms of the vision that I think the Prime Minister Modi had presented, he does want India to be at the cusp of leading change in AI. And I think because he publicly did mention it, I think it has trickled down to a large awareness. I think the India AI Summit, more than anything else, was for me a place where people went in and they saw what AI could do, right? Like, and it was always a very like esoteric term, And when you go into a conference where everybody is showcasing what AI can do, it suddenly becomes real. And then you start thinking about how you want to implement it in your departments, in your company, etc., especially because the whole country is gearing towards it. So I think there is that piece that is building up in the country. In terms of how are we really kind of contributing to it? I think because we are in the deep tech / AI space, there are very specific requirements around how around what needs to evolve. So, for example, we had given suggestions on how, like in Singapore, there is a way to kind of get investors to be more interested in deep tech, right? Indian investors have traditionally been focused on consumer tech. And that's because it gives returns very quickly. We had traveled to Singapore, and we had seen that the Singapore government actually does put in, like they give like 70% when the 30% is actually the risk is with the investor. Now that's a policy that is coming in. We've also given policy recommendations on how you can incentivize doctors to do cutting edge research in India, while I think in the US, doctors are by default incentivized to do cutting edge research. In India, in between their extremely hard clinical work, you have to really kind of get them to do cutting edge research with us. So there's a whole bunch of policy recommendations that we've given around those. I think around AI, our team had actually talked about like explainability and how software as a medical device, how you can actually make the path faster for AI devices. And there was a policy paper that had come out and our team had put in their ideas. Our team is also at the forefront of the DPDP implementation right now and are building an internal knowledge base and also presenting it outside. So there are all of these pieces that our team is working on.
And also the team members get called a lot for various panel discussions. We both are also called almost on every month basis in various panel discussions so there is IGF, where I have been part of IGF panel discussion for 2-3 years now, and they record those meetings and it is going to the policy makers.
Today, where we are, you think, a global AI company can come out of India, given all that you're seeing all around the world?
There are a lot of global companies. So Emergent is a Gen AI based Indian company, which is global and which is doing good, which is competing to ChatGPT, Claude, and whatnot, right? And I'm pretty sure there are more such companies which are usually not spoken much, but they are present in India and they are operating globally right now.
Yeah, I personally think you need I think somebody had used this word. You need a technology of ambition in India, and what I mean by that is everybody needs to be equally ambitious about building a world-class company, which means that you need investors who are more long-term thinking. You need the government policies to be more long-term thinking. You need the founders to have worked with international startup founders and then be like, oh my God, what am I doing? I need to be more ambitious in life, right? That technology of ambition, I think, is not very well formed in India. It needs to be much more well formed. There are pieces that are in place. And so there are founders, as she mentioned, who are going global, who are going despite the fact that ambition of technology is not really well formed. I think once that happens, you'll have an entire ecosystem. And then you'll also have things like the fact that startup founders in India, when you have technology of ambition, you need technology of failure as well, which means that as companies fail, you need to be okay with it, right? And so you need things like people openly talking about failures. You need things like the government being able to close today. Once a company is closed, I think it takes enormous amount of time and effort to kind of close it, right? So if you put that, you have immediately made it difficult for people to fail. And so then the only people who will come in are the people who are extremely ambitious. And so that's what I mean. There's the ambition of technology. The technology of ambition is not in place entirely.
Yeah, it's a wonderful way of kind of culminating this process. what has, coming to both of you as founders, what has been the emotional cost of building this organization?
Yeah, that's a lot. Like you are trying to unfold 7 years of emotional cost in one question. I think.
Where all has it impacted? Okay, let me try and break it down. I can do a 1 mm.
Yeah, it's. I think it would be different on different days. Like some days are really happy, whole team is accelerated, and like you feel really fulfilled. And it could be just next day it all falls apart emotionally. That can happen quite often. It's a roller coaster, and it is really. It does feel like roller coaster on daily
How do you
basis.
keep yourself together?
I mean, it's a hard, I think a lot of family support, right? Like, I think both of us have fantastic families who support us and who've been like husbands who have gone out of their way to support us, right? Like, and I think that really helps. Families, I don't cook at all. Like my family, my mom stays nearby. And so I'm so like traveling. I think in the past year, I must have traveled every single weekend almost, and it gets intense, right?
Yeah.
And so I think within that, being able to maintain a semblance of normality comes because family has been supporting, I think. So at least for me.
Yeah, it's
Yeah,
very
same.
similar. Yeah, it's very similar. Like it starts at the home. If you have all the required support at the home, your boundaries, your everything is required. Like if you need space, you have space. If you need people, you have people, and it requires encouragement, motivation. It requires motivation from outside as well, because this is something clinically that we are building at home. My parents still don't understand very well what I'm trying to build. I have explained them multiple times. Yeah, but also they are now that when they explain, they use different sentences and words, and it is so amazing to see how they explain now. They explain I'm mapping the brain, but then it is very difficult for them to explain how it is mapped. And it is very nice that they support. My husband is always there for support. I travel so much every month, in and out. I'm coming home, going back. Sometimes he doesn't even know when I'm traveling. Oh, today you're traveling. Okay, fine. And that's the kind of support we require, and it is there.
I think,
It has exists.
And in terms of the emotional toll, which you asked, right? Like, I think 7 years on a roller coaster on a regular basis, being able to say that, oh God, oh damn, that investor said no. Oh no, this is not working. Oh damn, the neurosurgeon said this and he screamed at our team. I think as a team, I think we have had to grow up really, really, really fast.
Does
And
the
to-
thick skin grow?
I am very thick-skinned, so I feel like I think the rejection really rolls off my back, because I'm always like, oh, that's a very important point that you've made. Now I need to think about it, and I go back and I think about it, and I'm like, correct. Now let me improve. So I don't take rejection personally at all. So it's very rarely now that I take it. I think when I was younger, I didn't. But what I mean is this whole roller coaster has taken its toll in an umpteen number of ways, right? Like I think in terms of how much time we spend with friends, how much time we spend with families.
So much.
Yeah, and our health, everything, I think it does take. And I think we have to, as founders, really be adults, and also you have to also manage a team which have so many different expectations, super ambitious, great team, right? And when you have to mentor a bunch of like super ambitious team members, you have to be more ambitious for them. Yeah. And so then you have to really get your this thing. I think they really push us quite a bit in terms of how we have to think. So then that adds to the work. So then you're like, oh my God, this is too much.
It cannot happen that one day your team is brainstorming, they are all accelerated, they come to you and say, oh, let's do this. And you're like, no, I don't want to do it. You cannot say no at many times, and you have to push.
As founder,
obviously
to double the excitement.
Yeah. Too much work.
How does one overcome self-doubt? Fears and insecurities are a given. So how does one really overcome it?
I'll tell you this thing. I don't come from a neuroscience background. I don't come from a medical device background. I don't come from a background of being an entrepreneur. Most of my families are engineers and doctors. So there is a lot I have to learn on the job, right? And I think one of my mentors told me, and I was like, damn, I don't know this. How am I supposed to go present this to a neurosurgeon, right? And he was like, what you have to learn as an entrepreneur is the fact that the surgeon in front of you, of course, knows more about the brain than you would ever. But what you do know is a very niche set of the brain, software, and building a company, which is a space that they don't occupy. And you are growing in that space. And that niche is where you grow. And you need to know that, and you need to accept that you will in some time, maybe in 2-3 sessions with the doctors, know that you are better at that niche than they ever will be. And that helps.
Yeah, I completely get it.
Facing the failure helps you to improve on the, and not taking it personally. Like she was also mentioning that we should rejections and failure, not taking it personally and growing with that and improving yourself eventually. So it's a cycle. Initially, I was very doubtful when I remember that point very markedly when we went to hospitals and neurosurgeons said that they would require something like this. And we were discussing and Laina was like, should we do this? Because it's a neurosurgery. I had immense doubt. Like we both were not in that space. How will it work out? Will it fail? People will think that we are fools. And at times there is nothing wrong being considered as fools. Fine, if somebody considers me fool, fine, I'm okay with that. So moving on with not taking the things
Taking
personally,
the plunge and not
bothering about yeah. Sometimes you need to take risk if you are ambitious, because to me, I don't want to be regretful when I'm at 60s thinking that I should have tried this. And possibly I was the best person to try it. I don't want to regret that in my 60s. And therefore, doing it now is the best possible way.
I'm going to bring in a slight gender lens here. Does overthinking ever come in the way?
I don't overthink too much on these matters, at least. I think I have a very peculiar trait that when I'm going into a thing, I don't overthink it. And then after the thing is over and I have performed in whatever manner, then I overthink, oh, damn, I should have done this. I think that it's like how fools rush it, right? I think I rush it.
So you go ahead and do it. So
and then after that, I overthink. And so my husband keeps telling me that the fact that he has to bear the brunt of my overthinking after the event, right? Like, but before it, I'm totally like, yeah, whatever. I'll go do it. It doesn't matter. I'll go speak to a neurosurgeon. It doesn't matter. I'll go stand in front of the Prime Minister and talk about our work. It doesn't matter. After that, I'll be like, damn, did I do this right? What did I do? So anyway, that works.
Yeah. I overthink. Yeah. So there is certain level of confidence that I have, and I have it from when I was a child, because I was in the performance. I used to dance. So that stage fear, I don't have that stage fear. And I go with that confidence. But post event, I will overthink. Post communication, I will overthink. Also for any specific detail, I overthink. Like yesterday night, I was thinking about, and that's why I mentioned about brain and dimensionality, because how brain perceives everything is, it is restraining us to think about the dimension beyond 4 dimension. And I was overthinking about it and I did not get a sleep till 3 o'clock in the night. So I do overthink a lot of different matters. And
how, at least, I mean, you need to come up and show up the founder the next day.
So I felt that it is more constructive when I write it down or note it down, because I'm overthinking about it, because at times I feel like I will lose the train of thoughts. And I don't want to lose those ideas and train of thoughts. And that's why I started writing it down. Some days I like get up from my bed, go to my laptop, write down something, and then go and sleep. Maybe after a week, I'm not even looking at it again, but then it helps me to write it down. Yes.
There was one person who told me overthinking is beneficial for us. It makes us more creative. It makes us think.
Yes, I do think that.
Yeah, maybe. I don't know. No, I think no. I think
it's different people process it differently.
Agreed.
you don't need to solve for it. It's one problem that doesn't require solution.
It doesn't, right? You overthink it, but it's good for you, right? Like, because that's why you set up processes. That's why you do things. That's why you learn and you do all of those. But yeah, and because you believe that the world can be a different place, doing what you're doing.
And I can give you a guarantee that she's also overthinking. I know it from her texts.
After the event, like
actually, both of us is after the event.
Yeah,
it's very seamless.
Yeah, I guess yeah, both of us do overthink, but after the event. Like I remember this one time I had some meeting, I forgot, and it was with a person I wasn't very sure. And then during the event, I was like, yeah, okay, whatever. I'm impressed. And then I came out and I had like a proper panic. Damn, what did I say? Did I do well? And Anurag's like, my husband is like, what do you say? Like, you finished the conversation. It's done. I'm like, yeah, true.
I have the same
You do?
from my husband saying, what's done is done.
I think, is it a girl thing?
I think it's a girl thing.
It could be. I don't know.
Which is why I said I'm bringing the gender lens when I brought this topic.
True.
But, so, in your own journey, what you've built and what you see of the brain, what makes you stay in awe? There has to be an awe factor without which you wouldn't be able to.
I always feel like we know nothing yet. Because brain, and this is two things. One, about the education, about the learning part, and also about knowing the brain. So these two are the two components which I always feel unravels itself in a way that I feel we are just minuscule, we know nothing. We, as a 56 people's team, also we know nothing at times. I feel that way because there is so much out there to learn, to know. When I was doing my bachelor's, I know, okay, these are the 10 different fields which exist. I was doing my master's, I knew, there are 5 more options that I have. When I did PhD, I knew even lesser, and now I just know about brain. So I'm knowing lesser and focusing more, and I know nothing. And that's how the brain works, and it is just amazing, so complex, and I'm always in the awe. And I'm in the awe of something in which I'm working. So I always feel that there are so many new things to explore always.
Liberating in some ways.
True. And for me, I think when so I think this goes back to the ambition of technology thing, right? Like when I go out and I see founders who raised like 200 million, 500 million for their work. And I'm like, damn, I need to be this. There's so much we need to do as a startup that we haven't done yet. There are so many changes that we need to make in the organization. We need to make sure that we are far more agile, far more ambitious, far more nimble than what we are today. And then I come back and there are like 100 things that I want to do. And I think meeting other ambitious people keeps you in awe, because then you're like, I could attain that particular next step, really.
Yeah,
I think
actually,
that's
I am when I see both of you. You've created something so fascinating.
Thank you so much.
Thank you so much. Yeah, I think that's the difference between us two. That's the awes for her and awes for me are slightly different, and that makes us very complementary.
True. Actually, true.
So we'll have a quick rapid fire.
Okay.
So who responds faster to messages?
I think she.
Oh, okay.
I would also pick with the podcast, yes.
Yeah. Correct.
Who takes bigger risks?
I think me. What would you say?
I don't. Okay, I have not measured it, so I don't know.
One AI trend you secretly dislike?
Oh, there are so many trends I dislike. Many in healthcare, there are a lot of IVs which are coming up, and they are optimizing it using AI. That I don't like it much.
Okay, you have one.
I don't like it when people say that they'll replace doctors and that AI will replace doctors. I hate that, because then they're basically taking off everything that an emotional doctor, the emotional quotient, the curiosity quotient, the IQ that a doctor brings, and they think that all of that can be put into a machine. I hate that.
Yes. What one AI prediction that sounds unbelievable to the outside but resonates with you?
I'll say in the neuro-AI space, I do believe that the fact that you could use the brain to train a model to answer questions similar to a chat GPT, I see movement towards it by different, like your chat GPT, your OpenAI, your Google, all of them are trying to do that. And I believe that that's a possibility, though I don't think a lot of people are looking in that direction right now.
Yeah. It's the correlation between the cosmic energy, cosmic uh, outside the universe and the brain. There are structurally and functionally a lot of correlations. There has been some articles, but it is not explored further. However, it resonates with me a lot.
What is one book that kind of changed the way you thought, behaved? Book in today's world, a series, a documentary, whatever.
Lots of them. I think there was this book called Intellectuals, which was about how each person who's risen to fame has had a very, very, they were all terrible individuals. And so I was like, yeah, okay, if everybody's a terrible individual, it removes the fact that I think it reduces the pressure on you to that you can also be famous or you can also do good work as much as these people, because they were in essence very human and very, very basic. Yeah.
And you don't need to be nice.
You don't need to be you don't need to be extraordinary to do good extraordinary things. You just need to make sure that you're appearing and making sure that you're coming in and doing those things. You don't need to be extraordinary, and that I loved.
Yes. I like the book The Incognito. And because each line of it, when it's talk about the brain, it has multiple layers to it. And I love, like, if you take 2-3 lines, read 2-3 lines of that, and you will have a lot of thoughts in your own understanding. Like, it is interpretable in different manners, and it gives you the prospects of what all brain actually consists. So, like, on the topic, and I also like a lot of recently I read a book of a Kannada co-author. It was a bestseller for a long time.
Banu Mushtaq.
Banu Mushtaq. So I like that.
Last relaxing holiday.
Oh my God.
Any memory of it?
Yeah. So I went to Philippines in March for 4-5 days with my husband. And that was really nice.
My proper one was I had gone to Brazil, I think, in 2016. That was my my proper, very good vacation. Since then, vacations have been work for me. So, yeah.
What's one productivity hack both of you go?
My productivity hack is essentially that I have a brain which likes to connect things. And which means that the traditional productivity hacks which try to kind of time keep aside a certain hour for something, etc., doesn't really work for me. I like when things are more fluid, and I work with that. Like I allow myself to mind wander, which I find
found a brain.
So now there are 2 parts to it. Number one, operationally, a lot of things are required in the office. So that is also productivity to me. So in a day, I think the whole thing flows for the operational work. A lot of operational work comes into the picture. The whole day actually goes on that. And then when I shut down those, that is when, like, other thoughts starts coming. Yeah. The other thoughts starts coming in and I start talking. Lately, I'm also discussing a lot of things with my husband on the creative sides of it, innovative sides of it, because he's also exploring a lot of AI driven things and evolution happening in the field. So I do that. And that is where I feel my brain becomes more innovatively creative. And that to me is the type of productivity I want more.
Interesting. Very interesting.
And that that comes after shutting down social media and other things, because social media is a huge distraction.
Distraction and a time sucker.
media.
Do you do social media, Laina?
I scroll Insta for sure. I think
Nobody.
I haven't learned the finance. So there are times when I say, okay, I'm going to shut it down for like 30
In 5
days.
minutes.
Yeah, no, so the 5 minutes okay. And then I think during Lent season or something, we're supposed to give up one thing you love. So it's like, okay, I will stop all Instagram and everything. My husband really laughed at that. He didn't really think that it would be possible. And so, yeah, I went back to it, I think, in 5 days or something.
Understood. Gym or sleep?
Sleep.
I think these days I'd like gym as well. Yeah.
Coffee or sleep?
Sleep.
Sleep. Sleep.
Life mantra in a life.
Keeping personal and professional separate has been the holy grail for me. And I feel that's the best.
Life mantra, my God. Tread lightly. I think this is I think the fact that you can do a lot in life, but you need to tread lightly. That's about it. Yeah.
You had one message for our viewers who could be founders, who could be career aspirants, women. What is it that you would have to say?
I would say that get everything aligned so that everybody around you pushes to be more ambitious. So the more you kind of make sure that everybody around you is pushing, the more you will anyway reach the top. So I think that so you make sure that your in-laws, your parents, everybody knows that you're ambitious. Go against them. Make sure that things you're doing you do things for fun, and things will then flow, I think.
Nice.
Take more risk, have no regrets.
Thank you.
Thank you so much.
Such
I
a
think
pleasure.
it was such a pleasure.
Such a pleasure. Wonderful. Wonderful.
Loved talking. Thank you so much. And thank you all. Thank you so much.
Thank you so much for listening to yet another wonderful episode from VWP. It gives us enormous pleasure to create this content for you. If you enjoyed listening to the conversation, please hit the subscribe button and do let us know your favorite moments from the conversation. We would also love to hear if you have any guest recommendations for us. Of course, please don't miss our shorts section where we have our favorite moments compiled in bite-sized formats for you. So keep listening, keep growing, and do subscribe to the We Women Project. This is your host, signing off. Thank you.